Dear students, welcome to the video lecture of Bitwise Operators Part 2. So first we are going to discuss about the Bitwise logical operator. Okay, the part is Bitwise AND operator. Ampersand symbol is used to represent the Bitwise AND operator. The output of the bitwise AND is 1 if the corresponding bits of the two operands is 1. If the two operands of the corresponding bits of the two operands is 1, then the resultant bit will be 1. If either bit of an operand is 0, the resultant corresponding bit is evaluated to 0. If one of the two operands bit is value is 0, the result of the bitwise AND operator returns 0. For example, consider the program given below. Here actually hash include stdio.h including the header file void main within the main, declaring a variable integer x, initializing a value it as a 1 and y equal to 3, x equal to 1, x initialize the value of x equal to 1 and y's value is 3. Comma and z is another integer variable. So here z equal to x and y. I am performing an AND operation between the x and y and store the value in the variable z, printing the value of x and y equal to percentage d comma z. So x and y equal to is a string. The value of x and y slash n is the new line character. The value of x and y equal to is a string. The percentage d is the format specifier of an integer. It will, after the double quotation and comma, it will look for the first integer variable and replace the value with the percentage, the format symbol. So z value will get printed here. So we'll see what will happen. The one's binary representation is okay. It's 16-bit representation, which will contain the value 0, 15-bit 0, and last bit is 1. The three's binary representation is 101. Okay, so 00 and 4 zeros again 40 40 0101. Now we are performing an AND operation. As per the AND operation, if the both bits are having a value 1, it will return a 1. If either of the one bit is 0, it will return a value 0. So we'll, as per result, we will see there 1 and 1. Okay, the x and y is performed, the value is stored in z. Okay, we'll see how it will happen. 1 and 1 equal to 1. Okay, the second bit is 1. 0 and 0 equal to 0. 0 and 1 equal to 0. So all other bits are 0. So it will represent 0. So 001 is a, okay, it is a binary representation of the value numeral 1. So our output value is 1. Okay, so we will see the program. We will execute the program and check the result. So here it's a bitwise AND operator. The same value which we discussed, integer x equal to 1 and y equal to 3, and another integer is z, declare 3 integer variable, initialize to x equal to 1, y equal to 3. I am performing the operation x and y and store the result in the z. As we discussed that the outcome, okay, I'm printing the value of x and y equal to percentage d z. Okay, as we discussed this, z will take the value 1 due to AND operation, z will take the value 1. We'll run the program and check the result. Okay, see the result. The value of the x and y which is equal to 1. Okay, what we discussed. Okay, the test case is succeeds here. Okay, as we discussed here. Okay, the output is 1. Output is 1. You will try some other values and check the output. Okay, for example, we will give the value x equal to 4 and y equal to 2. We'll see what will be the result. So the result is 0. Okay, because actually 4 is value is 1 0. 4's value is 100. Y's binary representation is 1 0. When you perform AND operation, all the bits will be 0. That's why the result is 0 here. Okay, this is the bitwise AND operation. Next, we are going to discuss about the bitwise OR operator. Bitwise OR operator is a single type symbol. Okay, the output of a bitwise OR operator is 1 if at least one of the corresponding bit of the two operand is 1. If the corresponding bit value of the any one of the operand is 1, it will return a 1. If both operand are 0, then only the bitwise OR will return the value 0. In C programming, bitwise OR operator is denoted by the type symbol. Okay. Here what I am doing an example program hash include stdio.h and void main. I'm declaring a variable integer x equal to 3 and y equal to 4. Okay, and another variable z which is not initialized, and z equal to x or y is performed, and result is printed, the slash and the value of x slash y equal to percentage d, the z value will be replaced here. So we'll see what will happen. X binary representation, x is 3, 11 is a binary representation of 3. 100 is the binary representation of 4. We'll perform the OR operation. So 1 or 0 which is equal to 1, 1 or 0 second bit, okay, 1 or 0 which is equal to 1, third bit 0 or 1 equal to 1, remaining are 0, all 0. So the triple one, so the binary representation equal numerand of the binary representation triple one is 7. So the resultant output is 7. Okay, we'll check this output, but it's OR operator. The program which we discussed, x equal to 3, y equal to 4, z, and performing the x or y, and the resultant value we got 7. We'll check the value, we'll check the output. Okay, the value of x or y equal to percentage d. Okay, the z value will be stored here. In the slide we discussed that. Okay, the value is 7. We'll run the program and check the result. Okay, see, yes, our discussion is correct. Or the value of the x or y is equal to 7. Okay, now I will change the output. Okay, x equal to 2, y equal to 4. We'll see what will happen. So in this case, the x or y value which is equal to 6, because the 2 is having value 1, 0 and y is having value 100. When performing our operation, we are getting a value of a 6. Okay, the value is 110 is the resultant bit. That's why the 6 is a equal numeral is 6. Next, we are going to discuss about the bitwise XOR operator. The result of the bitwise XOR operator is 1 if the corresponding bits of the two operands are opposite. It means such 1, 0 or 0 or 1, it will return a value as a 1. If both corresponding bits are equal, so 0, 0, 1, 1, it will return the value 0. So XOR operator is denoted by the cap symbol is used to denote the XOR operator. So we'll see example, hash equal sda.h, void main, integer x equal to 3, y equal to 4, and I declare a variable z, z equal to x, x or y is given. When I'm printing the result, slash in value of the x or y equal to percentage d z. So it will the string, then the new line character slash n is a new line character. The value of the x or y equal to the z value will be stored. Z is 7. How it happens? Okay, as per the bitwise XOR operator, if the corresponding bits are opposite, then it will be written 1. Corresponding bits equal, they will return the value 0. So here, what is a contradictory? Okay, 1 or 0. Okay, corresponding bits. Okay, x bits and y bits which are opposite. So value is 1. Second, if you take a second digit, 1 and 0, return value 1. Third, actually 0 XOR 1 value is 1. So remaining bits are equal. So that's why written as 0. So triple one is a binary, actually numeral of the binary percentage triple one is 7. How it happened? 1 into 2 power 0 equal to 1, 1 into 1 equal to 1 plus 1 into 2 square. Okay, so 4 plus 1 equal, actually, sorry, 1 into 2 power 0, 1 into 1 equal to 1, 1 into 2 power 1, which is equal to 2, 2 plus 1 equal to 3. And actually then 1 into plus 1 into 2 square, 2 square equal to 4, 4 plus 3 equal to 7. In this way, the triple is a actually this binary representation is equal numeral is 7. So 7 is our output. We'll check the output. We'll take the value as discussed. We take the value integer x equal to 3 and y equal to 4, and on the z we used to store the result z equal to x or y. So the output, okay, the value of x or y equal to percentage z. Okay, we discussed the value is 7. We'll run the program and check the result. Yes, the value of x or y, our test case is success. The value of x or y equal to 7. Okay. The another one more operator is bitwise assignment, which we discussed example in the previous video lecture. There are two more variation of assignment operator called bitwise right assignment operator greater than equal to, and bitwise left assignment operator. Okay, the less than double less than or equal to is a bit left assignment, bitwise left assignment operator. Double greater than equal to stands for the bitwise right assignment operator, because the shifting is stored in temporary memory location. Okay, if you don't give an assignment operator, then variable will take its old value after the execution. So you want to assign a value permanently, you have to use the assignment operator. The bitwise left assignment operator, okay, double less than which is equal to bitwise left assignment operator. This operator is a combination of left shift operator, and an assignment operator. Consider the following expression: value of x, left shift of equal to 2. It means that above expression left shift the content of the variable val by 2 bits and store the new content back to the val itself. Okay, storing the value permanently, we are using the assignment operator. Likewise, right shift operator, right shift assignment operator, bitwise right shift assignment operator. Here what will happen? The number greater than equal to 3, double greater than, that means right shift equal to 3. That means it will right shift the content of the number by 3 bits. Okay, right, and as well as store the value permanently in the variable number. That's why it is used. This is an example, okay, which we already discussed. X integer x equal to 5, integer y equal to 2. Before shifting operation, x equal to percentage d, y equal to percentage d, x comma y, x equal to 5 and y equal to 2. I am right shifting x equal to 1. Okay, right shifting x equal to 1. What will happen? The 1 will go out. Okay, another 0 will be added. It will become a 10. So numeral value is x is become 2. Why I am left shifting by 2? What will happen? Okay, here we will add and the 2 zeros will go out in the y. Another 2 zeros will be added in the right side. Okay, the 1 0 will become 1000 now. Okay, 1000. Okay, 1000's equivalent numeral value is 8. Another one is one's complement operator. Bitwise complement operator is an unary operator. It deals with the single variable. Works only with the one operand. It changes the 1 to 0, zeros to 1. It denoted by the tilde symbol. Another name is the negation operator. The one's complement can be obtained by using a tilde operator of a C. For example, the following statement will produce one's complement of y, an integer variable. Y is integer variable. When using a tilde symbol, it will produce one's complement of y. Okay. So, for example, what will happen? Integer y equal to 5. I am giving y equal to the negation of 5. That means it will initial value of 5 means 5 is 101. Okay, if you convert 1 into 0, 0 to 1, this is the value. Okay, and 4, 5 ones and 0, 1, 0. Okay, 0 has become 1, ones are become 0. All zeros are become 1. So the value is minus 6. Okay, one's complement of y is 5 is minus 6. Okay, that's it for the video lecture. So we discussed all the previous video. In this video, we discussed all the bitwise operator. You will try the bitwise operator for your various input. Okay, that's it. Thanks for watching the video.